So fuel economy estimates for automobiles built 1 year predicted a mean of 24.8 miles per gallon and a standard deviation of 6.2 miles per gallon for highway driving. Assume that a normal model can be applied. Use the 68, 95, 99, 7 rule to complete parts A through E. Let me get you started on this one. So let's first draw this out. I have a hard time looking at these. I definitely need to make these bigger. I can barely read them. So, and you may need to explode them a little bit more than that. And the font goes down for some reason. So I'm going to go ahead and draw this out on my paper first. So we have 64.8 is the mean and 6.2 for standard deviation. Okay, so let's start this out. We have 24.8 is the mean, standard deviation is 6.2, and let's go out one standard deviation from the mean. So it's going to be 24.8 plus 6.2, which is 31. Let's go out one more. Plus another 6.2 is going to be 37.2. And we'll go out one more. We're going to go out 3 standard deviations above the mean and 3 standard deviations below the mean. So we're going to get 43.4. I'm just adding 6.2 each time. Now let's subtract 6.2 each time. Okay, so one standard deviation below the mean is going to be 18.6. And then subtract another 6.2. That's going to be 12.4. And then we'll go out one more. And that's going to be 6.2. Does that make sense? I'm just going down 6.2 each time. So as you recall, let me change my pen here. So 68% of the data fall within one standard deviation from the mean. So 68%. Go here. And then we have 95% of the data go within 2 standard deviations of the mean. And then almost all the data, 99.7%, go within 3 standard deviations of the mean. So those are our numbers. Now let's see if I can find the right one to match it up with. Okay, let's see what we got here. No, not A for sure. Let me zoom in here to B. No, we did not get up to 49.6. So let's see what C looks like. Yeah, this is it, right? 6.2, 12.4, 18.6, 31. Yep, this is it. So C. And now we're just going to answer questions about that. So 99.7% of the data fall within what 2 values? And that's from 6.2 all the way up to 43.4. Okay, now using this rule, the 68, 95, 97 rule, what percent of autos should get more than 31 miles per gallon? So let me go back over to my homemade graph. Even though it doesn't look as pretty, I can think more easily about this. So I'm wanting to know, let me shade this right here. So this area right here. So what would that area be? So let's think about this. So this middle part is 68%. So what does that mean I have left in these 2 tails? Let me draw another one, maybe this pink tail. So what do I have left for that pink tail? It's 100 minus 68% is 32%. So I have 32% for both tails, but all I want is this yellow tail. So 32 divided by 2 is 16. So that is 16% left over. Okay, what percent should get between 31 and 37.2? So a couple different ways to think about this. So now we're looking for this area right here, from 31 to 37. So what do I know? So I know this area here is 68%. This is 95%. So I can subtract the 95 and 68. So 95 minus 68 is 27. And then that's how much I have left in both of these, like in both of the greens. But all I want is this green to the right, 31 to 37.2. So divide 27 by 2, you get 13.5. You know, and what you could do, you could actually label each of these 13.5. You could label each individual box, then it would just be a matter of adding up the boxes. That's what some people do. Sort of depends on how many problems you're going to be doing. And I can show you how to do this in StatCrunch probably in the next lesson. Okay, so describe the gas mileage of the worst 2.5% of cars. So the bottom 2.5% of cars. So what do we have going on here? So if that's 13.5%, so again, using our 68, 95, 99, 7 rule, if this is 95%, what does that leave me for these two tails? So I'll try to highlight these two tails. What does that leave me for that? If that's 95% and the whole thing's 100%, so it leaves me 5% for both tails. So this bottom part is 2.5%. So again, this little bottom piece here is 2.5%. These are each 2.5%. So that bottom piece right here is, there's my marker right there, 12.4. So they'd get less than 12.4. Looking good. Let me show you quickly how to do this in StatCrunch while we're here. It's good that you can use the 65, 68, 95, 99, 7 rules. It comes up quite a bit. So let me go open StatCrunch. So go up to question help, StatCrunch. Okay, so we're going to go to stat. You may not be able to see that. Let me pull it down. Stat, calculators, and it is a normal calculator. Okay, so we can do the mean. I've already forgotten them. Let me pull them back. 24.8, standard deviation of 6.2. So I can put these 68, 95, 99, 7 ticks, and there they are, right there. So I can put in whatever I want here. So for instance, if I wanted to answer what percent of autos should get more than 31 miles per gallon, so I'm going to say more than 31 miles per gallon. And it's 15.9%. This is the probability in decimals. But again, we're using these nice round number rules. So again, it's about 16%. And later on, we'll see how to do this exactly, and I'm kind of showing you how to do it exactly. Between 31 and 37.2. So here's where we click the between, and between 31 and 37.2. Okay, about 13.6%. 13.5%. Okay, do you see how that works? The worst 2.5% of cars. So again, using standard, the worst, so less than, and this is going to be 2.5%, so 0.025. So this little piece right here, we got at 11.3. Oop, I think I put that in wrong, didn't I? 2.5%. Thought it should be closer than that. So 12.6 is a better estimate, but again, it's an estimate. You know, with our choices, we get 12.4. That's what's sort of laid on with this rule. Again, these are just models that try to get as close as they can for these. So I hope that helps.